next lesson, we'll be talking about scientific notation. By the end of the lesson, you should understand the difference between standard and scientific and be able to change numbers from standard to scientific and back. So, standard form. In standard form, the decimal point determines the place value. For example, in this we have the same numbers, but the decimal point is after the one here and before the one here. So in the first number, it's $1, and in the second number, it's only 10 cents. Scientific, there's only one digit to the left of the decimal point. So no matter how big or small the number is, it's just one number in front of the decimal, and then this exponent is what tells us how big or small the number is. So to change from scientific to standard, it means we need to move the decimal to the end, because in standard notation, the decimal's at the end. So positive exponents means we move the decimal to the right. So if we start with 3.4 times 10 to the 5th, the 5 tells us go right 5 places. So we move that decimal 1, 2, 3, 4, 5, and we get to 340,000. Negative exponents means that we move the decimal to the left. So I start with 3.4 and it says times 10 to the negative 2, which means I move the decimal 2 places to the left and I get 0.034. One thing to notice is if you have a positive exponent, it's going to be a big number, 340,000. If you have a negative exponent, it's going to be a tiny number, 0.034. So to change from standard to scientific, that decimal has to be to the right of the first non-zero number. So in scientific notation, it's always one number in front of the decimal. So if the decimal moved to the left, it means it's a positive exponent. So the decimal right now is after the 2, and I need it between the 3's. So I moved it from after the 2 places to the left, which means it's 10 times 10 to the positive 2. If I have to move my decimal right, it means it's a negative exponent. So the decimal right here is before the 0, and I need it between the 2 and the 8. So when I move it 2 places, and I went right. So 2.8 times 10 to the negative 2. Remember again, positive exponent, big number, 332. Negative exponent goes with a tiny number, 0.028. So write each number in scientific notation. So scientific notation means right now the decimal's there, and I need it between the 1 and the 7. So if I rewrite it between the 1 and the 7, I have moved it from behind the 5 to 1, 2 places. 175 is a big number, so it's positive 2. Here, the decimal is right here at the end of the number, and I need it between the 2 and the 5. So, I'm going to move it 1, 2, 3, 4 places over, so it's 2.57 times 10 to the 4th. I can drop those extra zeros, I don't need them. In this one, the decimal is in front of the 0, and I need it between the 4 and the 5. So I know I'm moving it 2 places, which gets me 4.5, but I moved it to the right, so it's a negative. Negative exponent goes with a tiny number. Over here, the decimal is before the zeros, and I need it 1, 2, 3, 4 places, so between the 3 and 6. So I get 3.6 times 10. I moved it 4 places to the right, so it's a negative 4. Negative number, negative exponent goes with a tiny number. All right, to go to standard notation, from scientific to standard, the decimal is here, and this tells me to move it 3 places to the right. So I start with the 7, and I'm going to need 3 numbers, because it starts here, and I'm going to go 1, 2, 3. My answer is 7,000. With this one, the decimal is here. The 5 tells me I need to go 5 places to the right. So 1, 2, 3, 4, 5. So I start with the decimal here, and I move it 1, 2, 3, 4, 5. And so my answer is 290,000. This one, the decimal is here, but notice it's a negative exponent, which means I have to go left 2 places. So it starts here, and I go 1, 2. My answer is 0.08. With this one, my decimal is between the 3 and the 4. So I start with between the 3 and the 4. And I need to go 6 places. 1, 2, 3, 4, 5. So I'm actually only adding 5 zeros because 1, 2, 3, 4, 5, 6. So there it is in standard form. So let's do some more examples. So 1.35 times 10 to the 5th. If I go, this is scientific, so I want it in standard, I got to move that decimal 5 places to the right. In this one, it's in standard, I want it scientific. I need that decimal between the 7 and the 0, so I have one number in front of the decimal. 7, and it's a small number, so it's negative. Here, this is in scientific. I want to go standard, so I'm going to go 4 places to the right. This one is in standard to put scientific. The decimal is at the very end, and I need it between the 1 and the 5. So I have moved it 8 places. In this one, it's standard, and to have scientific, I need it between the 2 and the 0. I need that decimal in there. So I'm going to move it 2 places to the right. It's a negative exponent, tiny number. Here, 2.7 times 10 to the negative 3rd, so I'm going to move it 3 places to the left. It should be a tiny number. This one is in standard. Scientific means I need my decimal between the 7 and the 2, so keep that negative, but I had to move it 5 places. This one, 24 times 10 to the 3rd, is actually not even in scientific notation. Hopefully you notice that the decimal has to be between the 2 and the 4. So 24 times 10 to the 3rd actually means 2.4 times 10 to the 4th. So what form is 0.000569? That's standard form. What form is 5.69 times 10 to the negative 4th? That's scientific.